Hi, this video is another video in the stoichiometry unit, and it's on limiting reactants. So what exactly is a limiting reactant? Okay, well remember the reactants are on the left-hand side of the yield arrow in a balanced equation, and in a chemical reaction, if one reactant runs out before the other one, we say that it is limiting the amount of product that can be made. Because when you run out of a reactant, well, the reaction will stop. There's also the other reactants or in that balanced equation, which are called the excess reactants, and they are just in excess. Once that limiting reactant runs out, the other reactants are just present and they're unable to react because there's not something for them to react with. All right, so here's a good analogy. So this is an example of building a car. And so you have 8 car bodies and 48 tires. So those are the reactants. And the question is, how much product can you make? Well, the coefficient in this balanced equation would be a 1 for the car body and a 4 for the tires, because you need 4 tires on your car. So how many cars can we build? Well, with 48 tires and 4 tires per car, we could build 12 cars. With 8 car bodies, we can only build 8 cars. So our car bodies are our limiting reactant. And then once we build our 8 cars, we're going to have tires left over. That's going to be our excess reactant, and there would be 16 tires left over. Okay, well, how do we identify a limiting reactant problem? So far we've been doing problems and we haven't been concerned with this. Well, if you've noticed, you've been, and a lot of you have asked me about this, you say, what does it mean I have excess oxygen or I have excess this or that? We've been basically telling you that the limiting reactant is the other one. And so now we're not going to tell you that. You're going to have to figure it out for yourself. So you're going to have amounts of more than one reactant. And then whatever runs out first is going to be your limiting reactant. All right, so here we've got an example problem. You are reacting 2 grams of ammonia with 4 grams of oxygen. Which one is limiting? First thing you have to do is start with the balanced equation. And so if an equation is given to you, double check and make sure that it's balanced. Then you have to get moles of your reactants. All right, so we've got 2 grams of ammonia. We've got to get that to moles. We can't compare gram amounts of things. So we got to convert 2 grams of ammonia into moles. So a mole of ammonia is 17.04 grams. And when I get moles of ammonia, I get 0.117 moles of ammonia. And I'll do the same for oxygen. I have 4 grams of oxygen. It's diatomic oxygen. So it has a mass of 32 grams, and I come up with 0.125 moles of oxygen. Now you might say, oh, you've got more ammonia, you've got more oxygen, so ammonia must be limiting. But do not fall for that trap. Just because you have less moles of something doesn't mean that it's limiting. And I'll show you why in just a minute. Okay, so you're going to take the moles of each reactant, and now you're going to have to determine how much product can be made by using the mole to mole ratio from your balanced equation. The reactant that makes the least amount of product is our limiting reactant, and then that's what we're going to use for all of our calculations. Now, if you remember, we had the 0.117 moles of ammonia, we had the 0.125 moles of oxygen. And so the question is, well, why can't we just say that this is limiting because we have less of it? But look at our coefficient. It's a 4:5 ratio that we use here. So yes, we have less ammonia, but you use less ammonia as well. So what we do, there's many different ways to do these problems, but I think this is the most efficient way. What you do is you get moles of every reactant. So we've already said that. And then pick a product. It doesn't matter what product, and I'm just going to pick water, okay? Pick a product and do a mole to mole ratio and see how much product that each reactant can make. And so, I'm looking for moles of water, and my mole to mole ratio is 6:4. Remember, using your units is a great thing. So I could make with my ammonia, I could make 0.175 moles of water. Okay, now I've got my moles of oxygen from my last step, and we're going to do our mole to mole ratio, 6 moles of water for 5 moles of oxygen. And I come up with 0.125, nope, 0.150, excuse me, 0.150 moles of water when I use my oxygen. All right, now it's time. Which one of these? So you got moles of each reactant. You do a mole to mole ratio for any product. Just make sure the product is the same in both of your calculations. Whichever one made the least amount of product is your limiting reactant. And so in this case, oxygen is our limiting reactant. That's what LR stands for. It made the least amount of water. Okay, so from here on out, any question about amounts of anything about this balanced equation, we always start with our 0.125 moles of oxygen. You always start with your limiting reactant. Okay, so you use your limiting reactant and your mole to mole ratio to determine the maximum amount of product that you can form, and we would call that our theoretical yield. All right, so how many grams of water can be formed from the 2 grams of ammonia and 4 grams of oxygen? Use your limiting reactant. So we could just start from the top here. Even though we've done some of these steps, it's not going to hurt us to do them again. We are going to start with oxygen because it's our limiting reactant. All right, so when it runs out, our reaction stops. So let's just see how much water we can make from 4 grams of oxygen. And we got to convert it to moles, and a mole of oxygen is 32 grams. It's diatomic oxygen. Mole to mole ratio, what we want is water, and we're going to put moles of oxygen down here so that they will cancel. And then this is moles of water. And now they wanted grams of water. A mole of water is 18.02 grams. And our theoretical yield, the maximum amount of product that we can make, is 2.7 grams of water. Okay, so what I want you to do is I want you to try this problem and then bring it in. And we'll go over it as our warm-up in class tomorrow. All right, so we have got tetraphosphorus hexaoxide reacting with iodine to give us diphosphorus tetraiodide and tetraphosphorus decaoxide. All right, whoa, that was a mouthful. All right, you're going to start with 5 grams of this. So I like to put my amounts under it. So 5 grams, and I'm starting with 8 grams of iodine. Okay, so the first step you need to do is you need to get moles of each reactant. So make sure you do that. Moles of each reactant. Okay, once you get moles of each reactant, then you do the mole to mole ratio. And determine how many moles of a product can be made. And then the one that produces the most is not your limiting reactant. The one that produces the least is your limiting reactant. So use your mole to mole ratio to determine the amount of moles of product. The one that produces the least is the limiting reactant. And then you use the limiting reactant to solve the problem. So give this one a try. It's got some really odd coefficients in it, so I thought it was a good one to practice. So give it a try and see you tomorrow.